So I'm now going to time my bubble sort algorithm. So what I'm going to do is base it on a different one that we've done, so just to remind myself exactly what I've got to do. So here's one. So I'm going to use system nanotime. So what I'm going to do is have a for loop. I don't need, I'll init. Well, let's see, how many times shall I do it? I could do it, let's nick this for loop. So nick the for loop. So what am I going to do in the for loop? I'm going to init, and then let's go up to, I don't know, 100 just for now. So we're going to do, so now first we'll initialize our array, then we'll bubble sort the first I elements. So that'll be I. And then we want to time that. So what do? Well, here it tells us what to do. We set the time to be something like that, y.nanotime, y system.nanotime. So we do that after we initialize, and then we print out the new time at the end. There we go. Problem. So what we're doing is we're in our for loop, close the for loop. So we're initializing our array, sorting, recording the initial time, sorting the first I elements of it, and printing out the new time. And we're doing that for I starting off at 0 and going up to 100. So let's just compile and run that. So that's called bubble.java. So there we go. Now if we do Java bubble, so it went like that. So it did that very fast. So let's try and do 500 then. So we want a reasonable number of these things. So now there we go. Compile it and run it. So let's try and perhaps we can go up to 1,000, because that's moving quite fast. So let's right. Let's look at those numbers. So now what we want to do is we want to save them to a file and plot them. So if you remember how to do that, we put the output to a file, then we go into GNU plot, and we say plot, and then we put the file name, which was plot1. Good. So it's a curve. It's not a straight line anymore. We know from the theory that the bubble sort should be a quadratic. So we want to try and find the equation that matches, that goes with that, with this curve. So 100. So what do we get? We get we know it's going to be some function of x squared. So if you think 400 goes to about 100,000. So 400 squared is 1600. No, 400 squared is 160,000. And we've got 100,000. So what happens if we say a half x squared? So let's plot 0.5 times x next to that That's pretty good. So it's slightly more than that, so let's say 0.6 x squared. Perhaps 0.55. That's about right. So what we've done is we've shown that the time is related to the square of the size of the array that we're trying to sort in the worst case. So in other words, the algorithm, the bubble sort algorithm, is of order n squared.